I'm JP Vassar from Cisco System. I'm a Cisco Fellow and Head of Engineering for Machine Learning AI, and I'm delighted to tell you more about the Predictive Internet. That's a very key topic for Cisco. We've been working on this concept for about 3 years. And as you see, it's not just about the concept. We've been working on it. We have deployed many networks using this technology, and we'll be more than happy to share with you many results in the next coming month. All right, so let's step back a little bit and talk about the internet over the past 35 years. I do believe that we did a really good job at improving the ability for the internet to be more reactive. So to that end, we developed many protocols, algorithms, so that upon detecting an issue, which is usually a path issue, the path goes down, what we call sometimes a dark failure. At multiple layers, we can detect very quickly that there was an issue. And then once we detect a failure, we can reroute the traffic on an alternate path. This alternate path may be computed on the fly, or it may be pre-computed. We may be using optical network recovery technologies, IP technologies, MPLS technologies at all layers. We all know about fast IGP, fast triggering of SPF, incremental SPF, the use of one-hop or multi-hop backup tunnels with MPLS traffic engineering. So to me, the ability to react very quickly is almost a solved issue, but still we're not learning. And what I mean by we're not learning is the fact that you still wait until you have an issue and then you react, but you don't take advantage of what happened in the past. And this is what we need to change. So this is why we were introducing the Predictive Internet concept, and there's a broad set of technologies coming with it. So now if you think a little bit about the human brain is really about learning by experience. And this is what a baby does by sensing the world. And the brain is actually a very well-known predictive engine. It's a fantastic predictive engine. I won't go there to discussing about what we call predictive coding, but you do a lot of prediction when you grab a cup of coffee or when you play tennis. It's all about prediction. And of course, we do planning in the what we call the prefrontal cortex. But again, I won't go too much in there. What the Predictive Internet is about is really about the same concept. So I'm not claiming that we will mimic a human brain and all the things. We are far from doing that. That's not the objective either. But with the Predictive Internet, what we want to do is to, first of all, build a model of a world. And the world, in this case, is the internet. And thanks to machine learning with a rich set of telemetry, you can accumulate some knowledge. You can start building a model of the world and the internet at multiple layers, not just the routing layers. And then, if you can start doing that, you can start doing some prediction as well. And what I mean by prediction is the ability to anticipate issues before they happen. And that's really about, predicting the future. And of course, you can keep learning thanks to sensing. And sensing in this case is really about telemetry and figure out that you may make some mistake when you predict the future, but you will accumulate some data points so that you can start doing a better job next time. And of course, you can do planning. And planning is, of course, about automation. So these are very similar concepts. Again, the way it's being done in the human brain and the internet will be very different, obviously, but the two are, in fact, sharing they have a lot of commonalities between the two. All right. So as I said, what are the objectives of a predictive internet? The first one, I keep mentioning it, is about being proactive instead of being reactive. And I would say that they are complementary. Of course, you can't always predict everything. And by far, I wouldn't claim that we can predict everything. And so you're going to combine the predictive approach with the reactive approach for all the issues that we can't predict. It's not one or the other. They will work in concert together. The second concept that is even more important, I would say, equally important, is really the fact that instead of looking at a dark failure, when basically you have a loss of routing adjacency or you have a link that goes down, these are really the kind of failures we've been dealing with for a long time. And I think that it's now time to look at the application experience and the user experience and start to understand really how we can get feedback from the application so that we can take that into account when we do the best path selection. And the last but not least, of course, is about this concept of trusted automation. And we keep talking about self-healing networks. We haven't done much as an industry, but I do believe that once you can start doing some really good prediction, you can feed that feedback into a closed control mechanism and do the first step towards a self-healing network. Okay, so, sometimes when I presented this concept to people, they said, okay, you're trying to engineer, within IGP or across, the internet and do predict about what's going on. And that's not the goal at all. So I wanted to be very clear on that. It's not about IGP traffic engineering becoming predictive. It's not about intra-domain prediction. For that, we have many tools. We have MPLS traffic engineering, auto bandwidth, or using the path computation element. You can do offline IGP metric optimization, knowing the traffic metrics. There are many, many ways of doing that. That's not what I call the predictive internet. It's not either about inter-domain with BGP traffic engineering, for example, make it predictive. That's not what I'm talking about. What I'm talking about is the case where you can have a look at multiple paths across the internet, and you can go via MPLS, via internet. You can backhaul the traffic to a hub. You can send to a direct internet access. So the ability now of a system to do predictive path selection from the edge of the network, thanks to accumulated telemetry, and then you can run some machine learning algorithm to really choose the best path in a predictive fashion and not in a reactive fashion, so that you really understand the property of the path and what is expected from an application standpoint. And you can also make it predictive at the same time. And I really believe, after 3 decades in the network industry, that this is going to be a game changer. So what have we done? We've been working on the machine learning AI at Cisco for about a decade in many, many areas, going from security to collab to the Internet of Things to the SP backbone as well. And we started off with analysis, and you can't learn any model with a few thousands of paths. You need to look at hundreds of thousands and millions of paths, and that's exactly what we did across 2,000 service providers in the world. So we spent a big chunk of time trying to model this path. And what I mean by model, it could be a statistical model, it could be machine learning models, but we wanted really to understand the property and the characteristics of those paths. We also looked at seasonal aspects. Some paths may be seasonal. This is a very interesting property. We derived a bunch of advanced metrics to really characterize the property of a path with regards to an application SLA. We also look at multiple paths across a given pair of cities, across multiple autonomous systems, to see if we could find some clusters of paths having the same property, and we did the whole modeling on top of that. And that was, it took some time to do that. It's a lot of effort, a deep amount of expertise, so that we can really characterize what's going on. But that was not sufficient. The next piece was really to look at the application SLAs. So here, we won't have a time, it's a lightning talk, but I'm happy to point you to our studies where we look at the variability of the MOS core for voice. We looked at billions of records, not even millions, but billions of records, so that we truly understand the dynamics and the MOS core. So in this case, I'm just showing you a quick map. There's actually a video that goes on where you can see the variability of the percentage of calls with a MOS score below 4. And what you find out is that it varies all the time. Regardless of the region, even within a single day, you see the high variation. So what we did at Cisco was to understand the true SLA of the application. And we did that for voice, but not only for voice. We did it for Office 365. We did it for multiple types of applications. Now, when you understand what's happening in terms of application SLA, and you truly understand the dynamics of a network, and you have a large enough database, you can start designing a system that will become predictive. So this slide is a little bit hard to explain in a few minutes, but each heat map corresponds to a different customer, a different network. On the x-axis, you see the time. On the y-axis, you see some regions in the world. And when it is red, it means that we managed to save a lot of traffic from having SLA violations thanks to the prediction of the engine. So in this case, it's not just about predicting an issue, it's also about finding an alternate path with no issue. And we did many other forecasting things on top of that. The reason why I'm showing that to you is these networks are very different. For some of them, you see that it goes from being really good all of the path, then all bad. You see some other regions where it's more reddish, if you will, it's just in a given region. But then over time, it goes from having a lot of issues that we can predict and for which we can find an alternate path to some region where you can't predict, but you can predict, but there's no alternate path. And you know why this is so interesting? It's interesting because you see the need for constant learning, constant adjustment of the learning algorithm. And there's a reason for that. We all know about it. It depends on the peering. It depends on the high dynamicity of the internet. So with that, I'm going to my conclusion slide. And I'm sure that I will have many opportunities to talk to some of you to present more advanced results. Because again, it's more than a concept. It's really something we've been testing, for which we have a massive amount of data, and we'll be able to announce very interesting innovations in the coming months. But I believe that we need to enable the internet with the ability to learn. And learn means look at the past and encode this behavior in a model, then use the model to do some prediction. And I think that's absolutely key. The second aspect, as I said before, is that instead of only looking at the layer 3 and the routing adjacency or the path being alive with some fast keep alive mechanism, we need to start really to deeply understand the user experience. And for me, finding an alternate path is not about reacting or predicting when the layer 3 is down. It's also being able to understand that the SLA has been violated, the user experience is not good enough across the layers. So as much as I love this kind of prediction, this kind of layering, I also believe that we twisted a little bit the concept of layering when we looked at the IoT, for example. And the layering has been extremely powerful. It did allow the internet to scale, but sometimes having the ability to have cross-layer signaling so that we do understand the effect of the characteristics of a path that will make the application experience good or bad is extremely important. And I believe that is part of the predictive internet, to be able to predict, but also to find the best path, not according to layer 3 metrics, but layer 3 to layer 7 metrics. So with that, I'm very happy to share a bit more results. I did publish some white papers that you can find. There are many white papers being published as we speak. And of course, we have the opportunity to talk again in a few months with concrete results. And I believe that the predictive internet will be a true paradigm shift in the future. Thank you.
Thank you so much. Do we have any questions for him? While perhaps someone makes it to the microphone, I was wondering, do you have any predictions on when something like this will become more commonplace?
Yeah, it's a good question. I believe, it's not a question of years, for sure. We've been running this engine for about 1 year now, and at the scale of dozens and almost, I would say hundreds of networks. So we're probably talking about 6 months, I would say.
Wow.
Of course, it's a long journey, right? As I said, we've been looking at this engine for quite some time. I believe that the predictive internet is really about understanding the SLA from an application standpoint, get some layer 7 feedback, then be able to make some prediction and then close the loop. The closed loop control, which I believe is one of the most interesting aspects of that, will take some time. And that's why we introduced this notion of trusted automation. because of course the users want to see the accuracy of the prediction before trusting the system. But it's really around the corner. I believe this is going to be a game changer.
Okay. And we have time for one more question.
Hi, Alan Hannon from CrowdStrike. JP, I think it's about 27 years that Cisco's been presenting marketing as if it was standards. I'm curious, I think of science as the ability to predict and measure. When I looked at your information in your slides, all I saw were observations. Do you have any data about your ability to predict?
Yes, we do. So if you look at the white paper, there's a white paper where I'm sharing some data. As I said, when I say that we've been running this engine for quite some time, Alan, what I would say is when I started this initiative, I was skeptical myself. Because when you claim that you can start predicting stuff, you really want to make sure that you can really do it in a very reliable fashion and with a high diversity of networks. So we've been running that on small networks, large networks in multiple areas. And what we see is that for some network, we don't see a high degree of prediction simply because there's nothing to predict. On other networks, we can see that we can avoid more than 50% of all the issues that we see. So it's all based on real data. What I'm planning to do is to write a white paper within 3 months, probably, with accurate numbers. I just need to get the permission from these customers, as you can imagine. But yes, we do have a lot of real predictions that turned out to be correct. So it's not about replacing the reactive mode. We'll never replace the reactive mode. I wouldn't say that all of the predictions are correct. Sometimes there are some mistakes, but we learn from our own mistakes. And I think that now we reach a maturity that is high enough to make it a product. So I'm very happy to share again in a few months a bunch of results based on these networks.
What about false negatives or false predictions? Does that cause damage?
Well, it could, So do we have some false negative? Yes, we do. And that's why I do rely on a reactive mechanism to handle it. But when you play with machine learning, as you're using machine learning, I should say, you have a tension between recall and precision. So we tune the algorithm to have a high precision, meaning very, very small number of false positive. There are a few false positive. It is at the price of a low recall, meaning that sometimes you can have some false negative. But at the end of the day, what we do? We show the overall benefit. And what I mean by that is when indeed there is a false positive and you reroute for nothing, that's okay, but you may reroute on a path that is worse than the original path. In this case, we deduct that, we take it as a negative impact. When you sum up the negative impact and the positive impact, you have a very, very large benefits overall.
Thank you.
And again, that's something that I'll be sharing in the white paper. Thank you for the question.
All right. Thank you, JP.
Thank you.